terrestrial ecology, video 6. This is the last one. We're picking up, I think this is slide 105 out of 126. So, succession is a process where plants and animals are replaced in a specific area. So let's say, like we were talking about the grasslands, that the wildfires were very common. So in something like that, where the whole area is just demolished, you end up starting out with your annual plants, moving into the perennial plants, and this is stuff that happens over time. So you would start out with these basic critters, would be the first ones that came in, these basic plants, and then you'd move up to the more complex plants, and then eventually you'd have trees. So you can kind of tell the age of an area based on the plant life, almost. It's definitely not an exact science, but like an approximate. You know that a forest has been there for a while with these great big trees to develop, especially forests that have like the redwoods and those huge trees in them. So succession is how stuff is replaced by more complex species over time. Primary succession is the lifeless area. There's nothing there except rock or soil. And then the soil formation begins with lichen or moss. There is no soil, so you start with the bare rock, and then you have to have some kind of plants that can grow on bare rock, like moss or lichens, that will, as they die and decompose, turn into soil, and that soil formation is the first step in that primary succession. Secondary succession is an area where you already had a really strong community, but it's been either disturbed or removed, destroyed, something, but you have soil and bottom sediments already. So you have this stuff. This would be like the wildfire example, where you have that soil already, you had a really strong ecosystem, that wildfire destroyed it, and now you have to start again, but you have the soil to start with. The pioneer communities are called pioneer. Lichens and moss are called pioneer because they're the first ones there. They're the ones that branch out and start from scratch with nothing there. They're the first ones to kind of step in and get started with everything. Climax community is the area, it's the end. It's the advanced community. It's been there for a long time. The big trees, the bigger animals, plenty of plants. This is the older community. It's at the end. It's the climax. So if you look at the stages, you have the bare land, the rock, turning into the lichen, turning into the small shrubs. It's exactly what it would sound like. You start with nothing, and you go bigger and bigger and bigger until you hit the big climax community. You can see the same thing in an aquatic ecosystem, and we'll talk about that in aquatic ecology, but you start with just water with nothing in it, with a bare bottom, no sediment or anything. You have that underwater vegetation, that algae that starts to form, and then you have this temporary pond and prairie thing going on that turns into the forest and swamp communities. So the relationship to biomes and biodiversity is that they're constantly changing. We have stuff. There's environmental conditions that change. There are storms, hurricanes, wildfires, landslides. All of this stuff messes up. All of the geologic stuff, the way that the earth is changing and moving and shifting all the time, changes the biomes themselves, changes the plants and animals, and the plants and animals are forced to adapt and change and come back from that. The trick is that now we're having an impact on this, and so that's where we kind of come in. Humans have actually damaged or disturbed more than half of the terrestrial ecosystems in the world right now. So that's on top of what's supposed to be going on with nature. Like I said, the reset with the nature button is good. The wildfire every once in a while, the landslides, the big stuff is good. It comes in and becomes a problem when on top of that reset, we're now messing up stuff too. And so it just is not having time to get to those climax communities because it's being reset so much more than it was before we started impacting stuff. So the natural degradation in desert, you have these, cities are essentially a desert. You have this lack of soil, lack of plant life, lack of biodiversity. Off-road vehicles have messed up the soil. We've added salinization from irrigation. We've added nutrients and stuff to mess up the soil. We've gotten rid of groundwater, land disturbance you guys are very familiar with already, digging and mining and whatever else, the case may be, and then pollution from minerals. In grasslands, remember I said the American Midwest, the big thing in the grasslands is crops. We're turning it into crops. So it went from buffalo to cows, which, at a glance doesn't seem like that big of a deal, but you're losing that wild component, you're losing that natural biodiversity and turning it into what we need. And we're doing the same crops over and over and over again, which is depleting those nutrients out of the soil. They're not having time to replenish, and it's not being reset in a natural way. It's being forcibly reset every year, so you're not getting, again, those climax communities. Overgrazing is having an impact. It's not as balanced as it was before. The oil production and off-road vehicles and the tundra are a big negative impact on the polar grasslands, and then excess release of CO2 as well. In forests, we're seeing a lot of clearing of forests. You guys are very familiar with cutting down forests for livestock, for timber, for development, whatever the case may be. But we're losing the forests. It's that simple. The conversion of a natural forest with the biodiversity, with the different plants, with the layers, like I said, in the tropical rainforest, turns into just tree plantations where, yes, we're planting a tree to replace every one we cut down, but that doesn't necessarily replace that whole community and the animals living in the tree and under the tree and around the tree, and it takes more time for all of that to be replaced. So it's helping, but it's not like snap your fingers and it's back to the way it was. Still more damage from vehicles and machines and just all the stuff that we make, and then pollution as well. In mountains, agriculture is big, timber extraction is big, a lot of the same stuff as other areas. And we see a lot of increasing tourism and a lot of pollution, radiation from ozone depletion, and then off-road, again, soil damage seems to be the case in every single ecosystem. Building all these dams has a big negative impact that obviously is a huge disruption to the natural community in that area, or what was the natural community in that area, and it can't bounce back from that. I mean, there's no coming back from what it used to be. So development, essentially, we call it development. We build houses. We build houses. We build cars and roads and stores and whatever the case may be. But that essentially is destroying the habitat. So we eliminate the wildlife habitat to make our, you call it the urban jungle. So there's a bunch of different types of species that we can talk about and that we can refer to. A native species is what is originally in that area. A native species is what has always been there, was not introduced in any way. A non-native is one that migrates in, or that we put in, or that something else puts in, and it can be deliberate or accidental. So the big example that's popping into my head for invasive or non-native species, is you can also, let me write that down actually for you guys. You can also call non-native invasive species. You'll hear that a lot. One of the big invasive species or problems that we're having is with shipping now. So ships will bring in those great big cargo carriers. When they're full, are really heavy. So they're balanced. But then when they're coming back empty, they ride really high in the water, and that's not safe for them because they're bouncing around on the waves. So they'll take great big, thousands and tons of gallons of water, pump it into the hold of the ship, and use that to balance themselves in place of all the cargo weight. So what happens is that a whole bunch of critters come in with all that water, plankton, algae, a lot of larvae, juvenile species. Well, the ships will get to their new location, which usually is halfway around the world, and offload that water, and now all these new species have been introduced into this ecosystem. So it's accidental. They're not meaning to do that, but we have a whole bunch of invasive species now that have taken over and replaced the native species because they've outcompeted those native species. The native species have never had to compete against the new stuff, and they don't have time to react to it. So that invasive species in aquatic communities is becoming a real issue. So some examples of that. The Chinese chestnut had a fungus on it, and the fungus was the invasive species. It was controlled in China. It was, some plants were sick, some were not a big deal. But that fungus somehow made its way over to the American chestnut tree, and now the American chestnut was not able to compete with that disease, with that fungi, and so it's almost eliminated the American chestnut tree. The kudzu vine is the same thing. Kudzu is this plant that is, it's a vine. It's a spreading, branching vine. So you can see it covers everything, and it's incredibly fast growing. It's outcompeting a lot of the local plants. So you can see if this kudzu vine is covering that whole area, the plants underneath it it's covering are not going to survive because they're not going to be getting any of the sunlight and nutrients. That vine is going to be taking up the whole thing. So like I said, invasive species, they displace the native ones. They lower the biodiversity because they get rid of the local stuff. They can outcompete. They adapt very quickly. They contribute to messing up the habitat, and they reproduce very quickly. The issue with hunting, and let me just say for the record, I have no problem with hunting. I've hung out with hunters almost my entire life. It's very interesting. I've been out hunting before. I haven't ever gone after big game, but I would be willing to go. The problem is the overhunting and the people that don't do it in a smart way. So the problem that I personally have with hunting, and again, this is an opinion, so you guys need to kind of take all the facts and figure it out, is if you're hunting just for the trophy. If you're hunting just for the trophy, that whereas it might be really cool and a beautiful thing to see, is that really necessary, in my opinion, to have on your wall? Wouldn't you rather just look at it and take a picture of it and bring the picture back to look at? But on the other hand, if you're hunting, for meat to feed your family or to feed the town or whatever, then that is, that's what we've been doing. That's our natural niche, is hunter-gatherers. So that's my opinion. The problem, the facts are that overhunting has removed a lot of the top predators. Overall size in these big top predators and big animals is much smaller. Reproductive rates have dropped because the big healthy adults, especially the males, are disappearing from that population because that's what everybody's hunting. So if there aren't any males anymore, there can't be any babies because there's nobody there to make the babies. So those are the facts in the overhunting thing, and you guys kind of need to figure out where you stand on the whole hunting issue. Pollution. There's tons of it. We'll talk about a whole lot more of it in the spring. But just so you know, some of the more common ones is the CO2 pollution and the CFC pollution. Chlorofluorocarbons is CFCs from plants and chemical processing factories and stuff. Oil spills is a big issue right now, especially after what happened in the Gulf. Was that 2 years ago now, or last year? I don't remember. But there's a lot of issues with contaminants making its way into whatever ecosystem that it is you're talking about. So habitat restoration is something that's becoming much more popular now. It's trying to rebuild what was ruined. That's actually what the HIP to Habitat program is doing. That's what the Aquatic Science is going out to do this week, and you guys will take part in that as much as you can. And we'll talk about it some more, but essentially it's trying to, knowing that it will take time, but at least getting stuff started. So you have that succession, that path of succession. If we get a jump and we put the soil in there and we put some of the basic plants in there, that gets a jump start on rebuilding what was taken away through habitat degradation. Reclamation is returning vegetation that has been mined or to an area that's been mined. So, we have these great big pieces, areas of land that are all rock, all bare dirt, all whatever, because we used it, we dug holes, we blasted, we mined for oil, we drilled, we whatever. And so reclamation is taking that and returning the vegetation, replanting the native species back to that ecosystem, again, to help it get a jump on succession. So there's a lot of stuff you can do. You can replant the plants. You can try to remove the pollution. You can put laws down that you can't, continue, or you have to leave it alone. Any activity designed to fix that area is reclamation. So in agriculture, you have cut and burn techniques with the loss of habitat. That cut and burn, where you initially purposely start that wildfire or that fire on a controlled burn in order to quickly clear an area so that you can